Hi, Dr. Friends. Today's topic is about the glycolysis, which is most important topic for the medical PG exams. All type of the medical PG exams, which glycolysis is main important role for one question or two question. So let us start without wasting of time. Glycolysis. Glycolysis is also called as the EMP pathway. EMP pathway. EMP pathway. E stands for the embedden, Meyerhof, and P stands for the Partners pathway. This is also asked in the PG exam. What is a stand for P? So start with glycolysis. Glycolysis is a starting metabolic pathway of the glucose, and here the glucose is the fuel material for the ATP generation. This includes metabolism of the carbohydrate. It is the first step for the ATP generation. In the metabolism of the carbohydrate, first step is glycolysis. Next step is the connecting pathway, that means to the glycolysis and the Krebs cycle. Krebs cycle or TCA cycle. Then next to that is electron transport chain. These three are main important role in the ATP generation. Start with glycolysis. Glucose. Glucose is 6 carbon atom. 6 carbon atom, and terminal product is the final product is pyruvate. Pyruvate is the 3 carbon atom. 3 carbon atom. That means 6 carbon atom is converted into the 3 carbon atom. That means 2 molecules of the pyruvate. One glucose gives 2 atoms or molecules. 2 molecules of the pyruvate. Here the glucose C6H12O6 is converted to the glucose 6 phosphate. Here the enzyme required for that is hexokinase or glucokinase. This enzymatic activity have different part of the body, have different kinase, maybe of the hexokinase and glucokinase. Glucokinase mainly in the liver, and hexokinase found in the all tissues. I will upload the lecture on the hexokinase and glucokinase. So proceed with glycolysis mainly. Here the ATP is required for the transformation of the glucose to the glucose 6 phosphate, and magnesium required for this reaction, and this reaction is irreversible reaction. That means glucose is converted into the glucose 6 phosphate, which can't be back to glucose. And glucose 6 phosphate is converted into fructose 6 phosphate. That means glucose is converted into the fructose, which is also a 6 carbon atom. 6 carbon atom, 6 carbon atom, and due to its isomeric conversion, it requires isomerase, and it is a reversible reaction. Okay, next to that is fructose 6 phosphate is converted into fructose 1,6 bisphosphate in presence of the phosphofructokinase first, and here the ATP are required in presence of magnesium, and ATP is converted into ADP in both steps. One ATP required and one ADP is formed in first and third step. Here the phosphofructokinase is a committed step or also a rate limiting enzyme for the glycolysis. Here fructose 1,6 bisphosphate is formed and it converted to glyceraldehyde 3 phosphate and dihydroxyacetone phosphate. These both are 3 carbon atom. 3 carbon atom. It requires aldolase enzyme, and this is also a reversible reaction. Why I am asking about the reversible reaction, I will details on later. Another thing is here the first step to that step later on, this is a phase first reaction, that means energy requiring stage or investment phase. Next one is this is glyceraldehyde 3 phosphate and dihydroxyacetone phosphate is also a reversible reaction. Here glyceraldehyde 3 phosphate is converted to 1,3-bisphosphoglycerate in presence of enzyme glyceraldehyde 3 phosphate dehydrogenase. Here NAD plus is required, which is converted into NADH plus H plus. And here the 1,3-bisphosphoglycerate is converted to 3-phosphoglycerate, and here the ADP is required for that. That means ADP is converted into ATP in presence of magnesium, and enzyme are used phosphoglycerate kinase. Due to ATP is formed, so kinase word is used, and both these are reversible reaction. 3-phosphoglycerate is converted into 2-phosphoglycerate in presence of phosphoglycerate mutase, and this is also a reversible reaction, and 2-phosphoglycerate is converted into phosphoenol pyruvate PEP. Here the enzyme required for such is enolase and in presence of magnesium. Here the phosphoenol pyruvate is converted to pyruvate. Here the enzyme is pyruvate kinase in presence of ADP, which form ATP. In metal is used as magnesium 2 plus. In the glycolysis, the final product is pyruvate, and in absence of oxygen, the pyruvate is converted to the lactate. This is irreversible reaction. Sorry, this is reversible reaction, and is enzyme is the lactate dehydrogenase. Here the question is asked that the what is the dead end of glycolysis and what is the final product of the glycolysis. So don't be confused. The pyruvate is the final product, while that of the lactate is the dead end of the glycolysis. It is dead end of the glycolysis. Here, after the fructose 1,6 bisphosphate to pyruvate or lactate, there is formation of ATP. Here ATP is formed and NADH plus H plus is formed. That means energy generation. So this is phase 2 reaction and also known as energy generation phase, or also known as the payoff stage. Payoff stage. Here the NAD plus is converted to NADH plus H plus. That means hydrogen is added, so it is reduced. And here the ATP is formed in this stage. So this is also known as the substrate level phosphorylation. Substrate level phosphorylation. In presence of oxygen, only pyruvate is formed, while that of in absence of oxygen, lactate dehydrogenase is activated and it forms lactate. And in this reaction, this NADH plus H plus is utilized in anaerobic condition and NAD plus is formed. So in anaerobic glycolysis, there is loss of NADH plus H plus, which form approx to 2.5 ATP on the basis of new concept. So here you have to remember that the first phase includes glucose to fructose 1,6 bisphosphate, and phase 2 reaction includes fructose 1,6 bisphosphate to the pyruvate and or lactate, which are energy generation due to ATP are formed. Then in this reaction you have to remember irreversible, which is irreversible step. Then irreversible step start with first glucose to glucose 6 phosphate, that means glucokinase or hexokinase were used. Next one step is irreversible, is fructose 6 phosphate to fructose 1,6 bisphosphate, where phosphofructokinase first is used as an enzyme. Next irreversible step is PEP converted to pyruvate. Here ATP is used. 3 steps in the glycolysis are irreversible reaction, while that of all the steps are reversible. And main enzyme for the glycolysis is the first here the hexokinase. Next one is the phosphofructokinase, and after that is the pyruvate kinase. These 3 steps are irreversible, and enzyme, you have to remember three enzymes. Next one thing is the here the glucose is 6 carbon atom which converted to pyruvate which is 3 carbon atom. That means 6 carbon glucose is converted to 2 3 2 molecule of the 3 carbon atom. That means 2 molecule of the pyruvate, and this conversion is start from fructose 1,6 bisphosphate to glyceraldehyde 3 phosphate and the dihydroxyacetone phosphate. This conversion is also a reversible reaction. So 3 here or 3 here, this form one pyruvate and another this form another pyruvate. That means 2 molecule of the pyruvate. In this step, the ATP is used. That means where the 6 carbon atom, here the 6 carbon atom, here 1 ATP and 2 ATP are utilized. That means minus 2 ATP. And next step here, when it converted into split to glyceraldehyde 3 phosphate and dihydroxyacetone phosphate, there is formation of ATP, formation of 1 ATP and here 1 ATP. That means glyceraldehyde 3 phosphate complete a 1 cycle and form 2 ATP, and dihydroxyacetone phosphate also will complete a 1 cycle and form plus 2 ATP. That means here the 4 ATP are formed and 2 ATP are utilized. So net gain of the ATP in the glycolysis will be 2 ATP. Here the 2 ATP are formed. 2 ATP. And you have to remember all the enzyme ATP being utilized or ATP being formed, and which is phase 1 reaction, which is phase 2 reaction, and what is the final product, what is the dead end. And next thing is that this NADH plus is going to ETC. That means electron transport chain. Electron transport chain. This electron transport chain give rise to, in the older concept, 3 ATP and newer concept 2.5 ATP. So if we include the NADH plus H plus, then total net gain of the ATP will be 2 plus 2.5. That means 4.5 ATP. In case of anaerobic respiration, this NADH plus H plus is utilized in the anaerobic respiration. So anaerobic glycolysis. So this 2.5 ATP are lost in the anaerobic glycolysis. So then net gain will be only 2 ATP. So if question is asked, then net gain will be 2 ATP. In the anaerobic respiration, and in aerobic respiration 4.5 ATP gain. Here next thing is, if oxygen will present, then this pyruvate goes to converted to acetyl CoA. Acetyl CoA, and this acetyl CoA and pyruvate kinase is the connecting link between the glycolysis and Krebs cycle, and this acetyl CoA goes to Krebs cycle. Okay. Next thing asks that where lactate dehydrogenase is used, that means in anaerobic respiration, glycolysis, and lactate is the dead end. Where lactate is formed? Here lactate is formed in the lens, retina, RBC, testis, leukocyte, exercising skeletal muscle, renal medulla, and skin. You can remember it by a simple trick. L for lactate, L for lens, and leukocyte. Here 2 TE are used. So testis, you have to remember testis. Next one is, last word is E, that means exercising skeletal muscles. And next thing is that also a anaerobic respiration. Next one is formed is ethyl alcohol. Ethyl alcohol. Ethyl alcohol is formed in case of fermentation. That means fermentation, and fermentation takes place in presence of yeast. So this is not a cycle of glycolysis in the animal beings. So this is not discussed here. And here one thing is important, that pyruvate is formed, pyruvate form ethyl alcohol by losing CO2 and producing first, here is acetaldehyde, and acetaldehyde is formed, next to that is ethyl alcohol. It will be discussed on later, but main topic is glycolysis. Next is the inhibitor of the glycolysis. Here one thing is, first inhibitor is phosphofructokinase. Phosphofructokinase, I am making the scissor so that the enzyme is being cut by citrate, ATP, CMP, and glucagon. Four things you have to remember. C A G, CAG. C stand for citrate and CAMP. A stand for ATP and G for glucagon. Four thing which inhibit the phosphofructokinase, that means inhibitor of the glycolysis in the stage of phosphofructokinase first. Next one is glyceraldehyde 3 phosphate dehydrogenase. Here the inhibitor of iodoacetate is the inhibitor which prevent to form pyruvate. Next inhibitor at the enzymatic action of phosphoglycerate kinase. Here the arsenic which inhibit the phosphoglycerate kinase so that the glycolysis will not be completed. So thanks for watching my video. Have a nice day. Any comments, any advice, any question asking about the glycolysis, you can write in my comments box. Thanks again for watching my video. Have a nice day.